letter Z on there on purpose because we're going to see in a second that we don't get to use our Z-score stuff very often with this particular lesson, because in order to know the Z-score, you have to know this little symbol right here, and everybody should remember what this is, hopefully by now. This is the population's standard deviation. Well, if what I just told you was true, that very often you don't have a clue about anything about your population, then how can you know what this population standard deviation is? Real answer, you don't. So we're going to see as we go through this that this formula is going to adjust just a smidgen, which means we have to go into our calculators and use a slightly different program than we've used before. So today's the day where you guys are going to start seeing that all of us are going to have to do the area from the left, which means we're going to have to add back in that tail on the left side, regardless of which calculator we have. All right, so right now, if you have this formula and you know the population standard deviation, everything's the same like we've done before. But you'll see as we go through these notes, that's going to change, especially if you're looking ahead on the paper there. Okay, so in a randomized comparative experiment on the effects of calcium on blood pressure, researchers divided 54 healthy white males at random into two groups. One takes a calcium, one got the placebo. The paper reports a mean seated systolic blood pressure of 114.9 with a standard deviation of 9.3 for the placebo group. Assume systolic blood pressure is normally distributed. Find a 95% confidence interval for the systolic blood pressure of the placebo group. Okay, why can't we do a Z-score on this particular problem? Well, Mr. G, you got my percentage there. I'm just going to go plug it in, inverse norm, 0.95, everything's good, right? Well, no, we got to be careful because we don't know the population standard deviation. All we know is the standard deviation for instead the sample. So we actually have a letter S this time instead of the little circle sigma with the line on it. It doesn't seem like it's that big of a difference, but it is, because what if your sample has a really weird standard deviation in comparison to your population? So what you want to do to be more accurate is you want to switch into a different format that somebody came up with, and we're going to talk about it. It's called the student's T distribution here in just a second. And this is one that it's based on a normal curve. It's very similar to a normal curve, but it allows for some error because we give ourselves some leeway knowing that we're only drawing from a sample and we're no longer looking at the population of a whole because we can't. Sometimes we can, sometimes we can't. And so here's the information for the student's T distribution that's developed by a guy named William Gossett. Not that you need to know that, but it's there. It is continuous. It's a unimodal symmetrical bell-shaped density curve, so it's approximately normal looking. It's similar to the normal curve, but can be used when you only know the sample standard deviation, that's what the little s means, and not the population standard deviation. So it doesn't seem like a big deal, but it is if you don't know the populations, which we usually don't. The last thing here is important. It's based on degrees of freedom. So you have to allow yourself some leeway that you've made a mistake in your sampling. It just happens. Right? As statisticians, we know nothing is going to be perfect. I mean, weather forecast, everything else in life, vaccine percentages, all that stuff is our best guess. So we're allowing ourselves some leeway, and our degrees of freedom is always our sample size minus one. So we're going to take away one of our n's and say, we might be drawing a sample of 20, but the accuracy is really like if we only had 19 people, because we could have made a mistake. We're going to learn more about error analysis and all that as we go on. That's not important for today, but this little formula right here is going to be important. You might want to highlight it. It's on your notes. It says DF equals N minus 1. That's degrees of freedom is equal to your sample size minus 1. You're going to need that when you're using some of these different formulas. I don't have a picture of the differences. I don't know if it shows it on the notes or not, but the T distribution would look like it's a little bit more spread out and shorter. So like your normal curve, and again, this is just for visuals. This is not something that's like super important as far as test or anything. Your normal curve would look something like that. This would be your N for your normal curves. Your T distribution is going to look a little bit more like that one, which it looks very similar, but there's a difference between the two. This one's a little bit flatter and shorter, allowing for more area to be underneath the tail because you might have made mistakes or you might have made some errors, and so you might have some more outliers than you had before. So more area under the tails to account for S being less accurate than your population's standard deviation. Now, as you increase your sample size, we've learned this before several times over now, so this is still true. your t distributions will become more like the normal one, meaning the more people I take from my population, the bigger my sample, then the more that graph, this t distribution is going to look like the normal curve of the population because we're now getting more information from it. So that's why the overall rule of thumb is always a larger sample is better as long as it fits within our assumptions and stuff, which we will have to go back and check and make sure things are looking good on our assumptions like we've done before. So again, we're still doing all this scientific process. We're still doing all these reports. We're still writing our conclusions. Everything's the same. So a lot of your homework, a lot of your quizzes, and a lot of your tests are going to look like what we've already done so far, where you get 1 or 2 problems maybe, and you break a couple things down instead of like 15 or 20 different little, solving problems like we had with the probability unit. All right. So how do we find how do we find the actual confidence interval then if we're not going to use our z-score, if we're going to use t instead? This formula right here. So it's in your notes again, but you're going to notice that this has a t with the little, t scored, t value, critical value instead of the z-score. And that's because the main highlight difference is this right here. This is a letter S instead of the little, my handwriting's terrible, sorry, instead of this one. So this means we're using the sample's standard deviation and not the population. All right, so whenever you're looking at your word problem, and you'll have to make this distinction, it'll be a little tricky at first till you get practice. But when you're looking at your word problem, you'll have to identify, okay, did they just give me the population's information, or did they just take a sample and I'm limited to that? If they just took a sample and I'm limited to that and nothing in there says the population or overall standard deviation is this, then we now have to use this formula, which means we have to switch it to a t. I'll show you guys how to do that in the calculator. There is a program that does inverse t, just like inverse norm. But the problem with our calculators with inverse t is there's no left, center, right option. It's all just to the left, like everybody had to do beforehand. So even if you got the fancy calculator, it's not going to make a difference. You're still going to have to do from the left on these. So that's what you got to be careful as we go through it. So I'll show you guys. All right, so there's your formula. This is going to be important. It's, you can have either one, the top one or this one. You just have to carefully watch in the problem what it's telling you. So this is your point estimate. This is your average that they got from the sample. That's why it's X bar instead of the U. Again, this is going to be your critical value or your t-score based. This is going to come from your calculator based on the percentage you want. And this is all your standard deviation, just like we did before. Instead of the sigma symbol over the square root of n, we're now doing S over the square root of n. So the calculations are the same. Really, the only thing we got to watch out for is what we do differently here. All right, this whole thing, if you're curious, if somebody asks about it later or a problem comes up, is the margin of error, this thing here, because that's your plus or minus that's being added to your average. All right, so I know we had some questions on the quiz and on that very first unit, it's like, what's the margin of error? This is how you would calculate that. All right, any questions so far? I know we haven't really done any math yet, but just curious. All right. So how do we find the t distribution number, the critical value for t? Well, the first two we used to do, we're not going to do them anymore. So I'm just letting you guys know if you go to a college class, you might use them. We're not going to do that in here. So you can use a table, which is a nice large piece of paper with all the little values on it, like a z-score. We don't do that in here, but you could have that. You can also look it up at the bottom of the degrees of freedom on the sides. Again, we're not going to do that. We got fancy calculators, so we're going to use option number 3, inverse t. All right, we're going to have to add back in the tail on the left side every time we do this. If we don't, we're going to be at the wrong percentage. So I'm going to show you guys how to do that carefully. And then you have to remember what your degrees of freedom are on this one. It's always going to be your sample size minus 1. It's going to ask for that in the calculator. It's going to say DF, and you got to put in whatever the number is. So you're going to have to look at whatever your sample size was and then take away the one number in order to get the right answer inside of your calculator, because the degrees of freedom is very important. Again, that's that error that you're allowing yourself to have. If you forget to include it, things are off a little bit. All right, so we're going to find 2 of them there. We're going to find 90% and 95%. If I were you, after we find these, I would write these down in your notes because these are the 2 most popular ones we're going to use. Not the only ones, but definitely the most popular ones. So find a 90% confidence interval when n equals 5. Let me grab a sheet of paper here. Oh, my scratch paper got used up. We had quizzes, so un momento, por favor. Everybody got a calculator? If you need one, go grab one over there. Elizabeth, we make this morning, no accents.
Yeah, no, we're good. The bridge had exchange.
Yeah, I went over nice and slow after you guys told me how my people flipped out. All right, let me switch to my camera mode so we can type in things. All right, so we want to find the t-score or the critical value for t at 90% when n is equal to 5. So notice you have to have a sample size because if you don't, then you can't do degrees of freedom. So we want 90% when n equals 5. So you have to remember before we start typing things in the calculator, here's your t-score. It looks very similar to your n, but it's a little bit flatter, a little bit more wide. 90% is still, this is the area they want in the middle, all right, your confidence interval. So you're going to find an X bar and you're going to say you're 90% confident that it's between this and this. But in this calculator, as we're going to see in a minute, you have to include this. This needs to be added to your percentages. If you forget this right here, then you're going to be off by whatever percentage is missing on this tail, and you're going to get the wrong answer on a quiz or test and be confused. So if 90% of my area is what I want in the middle, then how much is left over here on the sides? Well, I have 10% left over. Somebody just said it very good. And it's split into 2 because you got 1 on either side. So there's 5% over here and 5% over here. So you have to remember that. So what I've told students in the past, this has just been my mental trick that I've used, always do 100 minus whatever it asks, get your answer and divide it by 2. And that's what you add back in to the situation. So in this case, 100 minus 90 is 10, divided by 2 is 5. So when I go to my inverse t in the calculator, I'm actually going to do it at 95%, even though I'm looking for a 90% confidence interval, because this calculator does not do a center option. All right, so second, bars, and you'll see it, it's number 4, inverse t. So we haven't used it before, but there it is, right there at that spot. So you press enter. It's going to ask you what your area is. Notice, no left, no center, no right. So it's going to assume doing it from the left every single time. So if you don't add that percentage in there, I can't stress this enough, you're going to be upset when all your stuff comes back incorrect. So we got to type in 0.95, even though we want it at this percent. Everybody okay with that? All right. Somebody's gonna accidentally forget it the first time. Hopefully you catch it and it doesn't matter. Now, what's my degrees of freedom going to be? Well, since n is 5, degrees of freedom is going to be 5 minus 1, which is 4. So you can't just plug in what you see on your notes. Notice we did nothing exactly like we saw here. We had to make adjustments every step of the way. So be careful, please. All right, we paste this, and then there's our answer. So we're going to get at 90%. If you want to write this down on your piece of paper, because 90% comes up a lot, you're going to get 2.1318. All right, this number is different than 90% with a z-score. I think our 90%, the z-score is 1.96. So we've got a little bit bigger space for our t distribution because we're allowing ourselves the option of we may have made a mistake here. All right, try 95 real quick, and then I'll put the answer up here on the screen, and we'll see how you guys are doing. So 95% when n is equal to 15. What's up, man? Yes, and you have to do that with the t because there's no left, center, or right, so we have to include that left hand. It's always default left on these. Does that make sense, David? Only because I would say I'm going to say no on this only because this is really the t number that we're finding right here. We're finding this one, and then we're going to do plus or minus, so that's also going to give us this one. So because it's only going to do left, we're never going to have to worry about this being included in the calculator. Otherwise, we'd always just be putting in 100%, and we'd never get the answer that we're looking for. But that's a good question. So always to the left. Good question. I like it. What's up, Will? Sorry about your thing being locked out the other day. The testing center unlocked one of my tests for somebody, and then they went ahead and put a code in, and I was not aware of it, and that's why it was locked out for you. So I apologize. Sir. I was like, what? There's no code. And I went in and looked. There was a code. All right, so for 95%, again, I'm gonna draw a quick graphic. You don't have to do this all the time, but I just want you guys kind of see what's going on. We want 95% in the middle. So we've got to include whatever this percentage is over here. So if you use my trick, 100 minus 95 gives you 5, divided by 2. All right, that's 2.5. So 2.5% has to be added back in. So this is really going to be at the 97.5% when we type it into the calculator. Your degrees of freedom, remember, is n minus 1. So 15 minus 1 is going to be 14. So you got to use 14 and you got to use that for your area. You just got to get used to making those adjustments for these t-scores. If you want to do this when you do your z-scores, you can just do it from the left. You do the same thing, except you don't have a degrees of freedom, but otherwise it's the same process. So second, bars, inverse t, now it's 0.975, and you're going to get degrees of freedom R14 this time. All right, so write this one down if you don't have it, because this is another popular one. 95% is 2.1448. All right, not saying we're only going to use those two, but those are very common. And if they're right there in your notes, you don't have to keep looking them up. All right, so again, any questions on this before we go back to the slides and we look at assumptions and do one of these examples and call the morning? All right. There's our numbers at the bottom there. All right, 2.1318, which we got, and 2.1448. Again, any questions on these? All right, when you're doing homework, and if you're allowed to use your notes on a quiz or a test, there's nothing wrong with having a little chart of the most popular ones just sitting there right next to you. Then you don't have to worry about the calculator ever causing you an error. However, with this t-score, just remember you have to do degrees of freedom. That will change. So at 90%, this might be different if I put in 10, but it should give you an indication that you're close. All right, so just remember, you're still going to type it in if your degrees of freedom change. But if you're using 5 and 15, those are common numbers, then you can, repeat it. Just be aware of what your situation is. One second. All right, steps for doing a confidence interval. You're going to recognize a lot of these. We're going to go through them again. So number 1, our favorite part, let's check our assumptions. Number 2, we actually do the math. And then number 3, we're going to write a statement about the interval and context of the problem. And then we're going to see later, we're going to then interpret that interpretation. So there's actually going to be 2 sentences we write, not just one at the end, because I know Elizabeth likes to write so much. I added one just for her. No, I'm just kidding. I did not create all this just so Elizabeth would be happy today. But you will write 2 sentences now. Just be aware. I don't want you to be shocked when you get there because you have to interpret the interpretation. All right. What are all my assumptions for the means? Well, first one is the same as we've done before. Is your sample random? We've done this with the confidence interval, looking at some of your guys' work. I haven't finished grading all those yet, but you guys did, for the most part, a good job. You said it was random sample, same thing here. All right, so that's still going to be there. Now, number 2 is where we start to change things just a bit. You have to decide which one you're going to be using, Z or T. Okay, so you have to go back into the problem and see, did I get population information or did I only get sample information? If it's population stuff, I can use Z. It's better, it's more accurate. If not, if they only said based on a sample of, then we use T and we go forward. Once you know which one, you just got to tell me why you're picking it. It's very easy reasons. I'm picking T because this is unknown, or I'm picking Z because I know it. So you just have to write one of those. You don't have to do both. And then the last thing you have to do for the averages, so this is not as, you don't have to do the N times P, because is there any percentage here on this one? No, so we don't have to do any of that formula. The last thing we got to do is just prove that it's normal. So the assumptions on this are actually fairly easy. You just got to prove it's random. Tell me which one you're picking, and then tell me how you know it's normal. Remember, the easiest one is, they told me, like our first example we looked at. Second one, I have a sample size that's bigger than 30, so I'm good. Or, and the one we learned a little bit after we were going to learn after the quiz, that's one thing we did forget, is we can use a graph. If this comes up, I'll show you guys how to do it real quick, because this class did forget to get that on Thursday. All right, there's our assumptions. You do all your math. Again, you only have to use one of these down here. So Riley doesn't have to click through all 3 of these. He's either going to say it's given to me, it's 30, and I'll show you guys how to do a graph one, actually on the first example, because we don't have what we need. It's easy. The notes are going to be uploaded to Canvas later, so you can go back and watch like a 5-minute set of notes that we did Wednesday after the quiz that you guys didn't do. I'll show you how to do it real quick. All right. So we say memorize this because eventually when it comes to AP testing time, you are going to have to memorize it. But as of right now, when you're learning it, it's right there in your notes. Okay, so the first one is your conclusion statement. We are whatever % confident that the true population mean, not proportion anymore, of all is between this and this. So that looks very similar, almost word for word what we used before. What's in addition now is this last little statement that we haven't done before, the interpretation of that confidence level. And so this is basically going to be your sentence that you repeat over and over again. You just have to change the percentage basically and the name of the population and the size of your N. That's it. You just got to fill those in, but otherwise your sentence is the same. So you're going to say, if we repeatedly took samples of whatever my N is from the same, whatever your population is, and calculated whatever your interval is, approximately, again, your interval of these would include the population mean, proportion, whatever. So it's just highlighting the fact that you understand kind of what the sentence is doing. If you don't understand, that's okay. As we do more of these, you'll start to get comfortable with them, but this is the last thing you need to put on there. Don't forget to include your context, your units when necessary, and all that kind of stuff. So with all that out of the way, let's go ahead and kind of work on one together. So Consumer Reports tested 14 randomly selected brands of vanilla yogurt and found the following numbers of calories per serving. So the first thing I notice here, and this is supposed to be a space between 80 and 120, there's not 80,000 in one of them. We're going to compute a 98% confidence interval for these. So I don't have that this is normal, and I don't have 30 of these to say that it's normal. So we're going to get to do what you guys missed on Thursday's class. And again, it only takes all of like 5 minutes to show you, so you should be good. So let me switch it over to the camera and let's do one of these from scratch. All right, so the first thing you have to do is your assumptions. All right, so what are the three things that we have to go through? We need to prove that it's random. We need to decide if we're picking Z or T, and then we need to choose one of these to say it's normal. So number one, simple random sample of, there it is right there, randomly selected brands of vanilla yogurt. So I'm just gonna say yogurt. Check. So there's my random because of this. All right, number two, which one are we going to pick here? Well, Consumer Reports tested 14 randomly selected brands of vanilla yogurt and found the following numbers. I see nothing about the population of yogurt here. I just see information about these 14 brands. So we're going to use T, and we're going to say because the standard deviation for the population is unknown. Does that make sense why I picked that? I have no standard deviation at all, so I really have nothing to go on. So for sure, I don't have anything for the population. So that one's number two. And then for the last one, number three, we need to write out or prove how it is normal. So normal because, and here's where we have to look at our options. Well, option one says it's given to you. Nope, doesn't say it in here anywhere that it's normally distributed. All right, number two says sufficiently large, meaning our sample size is bigger than 30. Nope, there's only 14 there. So we get to use option three, check graph of data and double check that the plot is linear. So we get to do one of these together and then you guys will be all caught up. So type into your calculator these 14 numbers into your list. So you go to stat, edit, and I'm going to use L1 for my list here. You guys can use whatever one you want, but we're just going to type them in. So do your thing. All right, so all my stuff is in there. Double check that you've got 14 entries and everything should be good. All right, so the first thing we want to do is prove that this is normal. Don't start doing calculations yet and wasting your time if it fails assumption number three, because it might. And it's unlikely, but it might. And then you're going to waste your time doing something you don't need to. So to find out if this is normal, we got to go back to our little stat plot graphs that we did way back in the fall. So you hit second, y equals. My stat plot is already on because I used it the other day. Yours is probably off. So hit enter on number one and switch it to the on mode if it's not. And then when you go down to your graphs, we want the very last one way down here. It'd be nice if they put labels on these, but for now, just know it's the very last one. Once you got to this point, all you got to do now is hit graph. you're probably going to be seeing something that looks like this because yours is on the default setting. So how you look for it is you hit the zoom button, and if you remember, we go down to number 9 since we're looking at statistics. So when you do that, you're going to see a graph. If all of these dots look straight or in a line, then you're good to go. If they look at all like curved or S-shaped or something weird, then you're not. So you're going to say normal because, and then you can just type in that the plot looks linear. So say, draw a little picture here. Here's my graph. Doesn't have to be anything fancy. And just like, there's what my thing looks like. And you can just say, plot is linear. That's it. Now we've proven that this is normal, so we can continue onward. So what this does, if you're curious how this graph works, it takes all of your values, these, and places them in the X part of the graph. And then it makes a Z-score for each of them on the Y-axis, and it puts them all together. And if they line up straight, then they're going to fit where they're supposed to in a normal curve. And so this is a graph that was, designed specifically to determine if these are straight, then your data is normal. That's it. So you don't have to worry about anything else. Okay, so there's our assumptions. Questions so far? Yeah, you bet. So you hit the second button, and then the Y equals button. It'll bring up, you can always plot data. And then I just press enter on number 1 and make sure it's turned on. Because if it's highlighted over off, you won't see anything. And then go down here and make sure you're on the very last, that last graph there. And then you don't need to worry about anything else. If you want to change what your little marks and colors look like, you can. If that makes you feel happy that it's like red or something, that's fine. And then you hit the graph button when you're all set, and then you should see it. If it looks like this, David, that means you're still in the Zoom 6 standard mode. So you can just hit zoom and then go down, or hit number 9, and it'll put them on there for you. So is that working? Gave you an error. Does your list maybe have something? Okay, give me a second. I'll come over and look at your thing. So, all right, but this is what it's supposed to look like. So when we get yours figured out, yours will look the same way. So don't change too much. I'll come over and look at it, and we can see what's up. All right, so you got your assumptions done. Now you got to do your calculations. So for your calculations, you're trying to find the upper and lower bound of where you expect the, average of the calorie content per serving of vanilla yogurt to be. That's the whole point of this. We're going to do it at a 98% confidence interval. All right, so the formula we're going to use is the X bar plus or minus the T-score, because that's what we chose earlier. We're going to use T. And that's going to be multiplied by the sample standard deviation over the square root of n. So this formula is actually easier to use, in my opinion, than the ones we did with the percentages. Now, we need to know this information, so we're going to get the calculator to help us with this, and help us with this, and help us with this, and really the only thing we know so far is n. Because we know we have 14. All right, so let's figure out these things here real fast using our calculator. So now that everything is in your list here, what we can do is hit the stat button again, go over to calc, and we can just do an analysis of our data. We've done this before. And what it's going to do is tell us what our average is, what our standard deviation is, et cetera, et cetera. So notice we have 2 different standard deviations to use. We want to use the S one because we're doing a sample. All right, so X bar 157. Point, I'm gonna go out to 4 decimals like we always do, 8571. All right, our standard deviation of X is going to be 44.7521. All right, so I'm getting it from this one right here. So there's 2 different deviations. We care about the sample one. We're not looking at the population right now. This one's just estimating if this is the population. This is the one we want to do. Now, what's cool is it reminds you of what your n is. So what's our degrees of freedom going to be here? 13. Very good, because we're going to do 14 minus 1, which is 13. So it's nice to have all this written down so that when you do your calculations, you're ready to go. We just got to figure out this number at 98%. All right, so when you try to figure out your T-score at 98%, you're going to go second, vars, down to inverse T. Remember, it only does it from the left. I want a 98% interval, so I've got to add in the left side here. So 100 minus 98 is 2. meaning how much percentage is left on the left side? 1. So I'm going to do it at 0.99 for this one. Does that make sense? Yeah, make sure. And then degrees of freedom, again, 14 minus 1 is going to be 13. Press enter. And then this is going to be your t-score for this problem. So 2.65. And then we've got what? 0.3. All right, so now we can plug all this mess into our formula here. So what is our X bar? 157.8571. I'm going to do the minus first. So minus. What's our t-score? 2.6503 parentheses. And then we're just going to multiply by this fraction here. So alpha y equals enter, just like we've done before. What's my standard deviation? 44.7521. And then what's going to be my actual sample size down here? 14. So you don't do the degrees of freedom down here. Oops, sorry, got to do the square root though. You have to do that, Mr. G. There we go, square root of 14. And then close parentheses. Questions? X bar, t-score, standard deviation size divided by square root of 14. Press enter. This is your lower bound. So my first number is going to be 126.1582. All right, what's my upper number going to be? Well, we can go back up here, highlight it, make it a plus. Again, the formula for this is not as complicated as the other one, I don't think. We're going to have 189.5560. All right, these are calorie content. I don't know what the unit is for these because I'm not didn't say. So we're just gonna leave it as numbers right now. I'm not an expert on, health science, so I'm not sure what all the numerators are. But this is my lower bound. This is my upper bound for this interval. So there's not much room here. So if you want to write the sentence on the next page, you can, or you can go back and look at these here in a second. But we would have to write out our sentence that says, we are 98% confident that the population mean of all vanilla yogurt calorie content is between, and then you put in your two numbers, 126.1582 and 189.5560. Then after you've written that sentence, you would then write this one right here. If we repeatedly took samples of 14 from the population of vanilla yogurt and calculated 98% confidence intervals, approximately 98% of these intervals would include the population mean of vanilla yogurt. So you substitute all that in. All right, again, the space on here is a little limited, so I'll put that up on the graph on the board here in just a second. All right, how we feeling, guys? Any questions on this? I know it's a lot on a Friday that you thought you were gonna get to sleep in. Here's all my stuff. Actually sketch a picture we did. Degrees of freedom 13. There's our calculation. So again, notice it used 44.7521, not the 43 there, because we want the sample standard deviation. So a lot of little things can go wrong. Be very careful with your analysis here. What's that mean? You don't need to, because there's no percentages there. So you can just leave it blank. How different? Like a lot different or a little bit different? Okay, let me look at what you got typed in there before you erase it. And I got to look at David's thing too. You figured it out? Okay. Okay, sometimes that works too. The on-level kids use this for different things, so they can always go in and change your sentence. Okay, so there's your sentence right there. If you have room to write it down, great. If not, you can put like a picture of it there later, or say see slides for information. So this way you guys have an example. I'll check out your numbers here in just a second. I'll put a number in, it happens. And then again, don't forget, you have to write that other interpretation. Now, looking at example 1, continued part B, I went ahead and put the answer up there because time's getting short, but I want to kind of go over this. When a diet guide claims you're going to get 120 calories from a serving of vanilla yogurt, what does this evidence indicate? Well, since 120 calories is not contained within my 98% confidence interval, the evidence suggests that the average calories per serving does not equal 120. All right, so I have this interval that goes from, we just calculated it, our interval goes from 126.15 82 all the way up to, so our X bar is somewhere here in the middle, all the way up to 189.5560. So for part B, the diet guide's claiming this. Well, sorry, diet guide. I know where you're talking about. You're back here somewhere. What's up? So since it's outside of my interval, this is where I expected it to be. And I gave it a wide interval, right? What was our percentage that we gave it? We gave it 98%. So this diet guide must have just grabbed like one. It was like, hey, cool, 120 calories. Like, no, not happening. So part B is that they're wrong. All right, we did an analysis of 14. I don't know what they did. So they're a little weird there. All right, so part C was that second sentence I was talking about. All right, any questions on this one, part B? We good? Being able to do it. So some of your problems are just going to say, hey, we got this. What does it tell you? It's in or it's not in. All right, here's your interpretation from the previous one. So if we repeatedly took samples of 14 different vanilla yogurt brands and calculated 98% confidence intervals for the mean calories per serving, approximately 98% of the intervals would contain the population mean number of calories per serving of vanilla yogurt. So what this is saying as you're writing this out is I've got this population that exists out there of vanilla yogurt. And here's my little bubble that represents, yay, population of vanilla yogurt. All right, I have no clue about anything in the population other than, they sell it at the shelves. So I'm starting to pull samples out of it. One of my samples here is 14. I'm going to do another sample, it's 14. I'm going to do another sample, it's 14. I'm going to do another sample, it's 14. We can do this as many times as we want, so infinite amount of times. Each one of my samples has a 98% confidence interval that X for this sample is going to be between a certain range and a certain range. So if I keep repeating that over and over again, 98% of my samples are going to have the true population's average. Again, I don't know what the actual answer is. I don't work for Yoplait or whoever does yogurt. Okay, I don't know what they're putting into their food. I'm a statistician. I'm trying to find it out from the other side of the problem here. I work for a diet agency or a personal trainer for people that need help. Whatever I do, I don't know. All right. So since I can't go to Yoplait and spend millions and say stop your production and let me measure all of your yogurt. I'm going to take small samples at different places over time and realize, okay, 98% of the time I'm getting it's between here and here. So I'm that much confident that the real answer is in. And then I can start giving people information saying, hey, if you're trying to be on a low calorie diet for weight, consider this as an alternative or stay away from this if it's too much or whatever. All right, that's how these things are done. So it doesn't matter what job you're going to be in, somewhere along the way, somebody's going to need stats on something. And if that's something you want to do, this is kind of how you figure out what's true about the population when you don't have all of that information in front of you. So we will stop here because we only got about 3 more minutes and I don't want people to be late leaving class. We will do example number 2 if we see each other Tuesday morning. If we don't, because there's 15 feet of snow on the ground, like that happens. But if that's the case, I'll send out an announcement on Canvas and let you guys know what's up. I try to do it early enough so that you can just roll over, look at your announcements and go, oh, Mr. G said we don't have to come in today. And you can go right back to bed because I know this class is early. And if you can get an extra hour of sleep, that makes you happier. So I will try my best to do so, barring no power issues, internet down, all that kind of stuff. So just keep watching the notifications. Our quiz is still right now scheduled for Wednesday. The quiz will only cover hypothesis test of proportions, which we learned like earlier this week before we took the quiz. So if you need to go back and watch those videos, they are on Canvas. You should be good to go. If you're not sure how to do those or you got questions, you can start messaging me. I don't know if I'll be available for tutoring or not because we missed meetings yesterday. So if I know for some reason I'm not going to be here, I'll post an announcement too. Says, hey, sorry, my tutoring thing is a little busy today just because we missed like 2 or 3 meetings yesterday. Also, for the most part, I think I've got the grades caught up. If you feel like I haven't gotten one of yours caught up or you still need to do a makeup for something that's a 0, make sure you're getting it done like today or tomorrow because grades are still officially due by Monday morning. And if you're expecting me on Sunday to check it at like 9:30, you might be a little disappointed because I'll probably be in the middle of a video game session with my brother and my son and I'll forget about this stuff. I don't want you to be disappointed. I'm just letting you guys know now. We're gonna play some Civilization, and being that it's cold and we can't go nowhere, we're probably gonna start about lunch and we'll be done about dinner. So I'm gonna go find where my son's hiding on the map, and I'm gonna gang up on him with my brother and beat him up. That's the funds of fatherhood right there. Father of the Year award. You guys know how I am in class. Just imagine me at home with somebody I don't care about what they're doing. All right, that's it, guys. Thanks for showing up this morning. I know it's cold. It's only going to get colder. Sorry. If you like it, it's going to be cold, then lucky you. See you guys on Tuesday, maybe. Bye. And you guys in here, you can go. Let me see. You guys want to get my memory of everybody who's here real quick? Okay, so we're just missing Emily. You guys are good. Okay. Oh, and see you guys later. Be safe driving. I think the roads are good, but don't tailgate somebody too much. No aggressive driving, Elizabeth. Which one? The one from the other day?
Yeah.
Okay. I won't put those, just so you know, into the grade book, like the confidence interval ones for this unit until the next one.
Okay.
So I'm not gonna like throw a zero at you when we only have like one day to look at it, because I
Can I
mean,
do it over the weekend?
yeah, I'll open it up, no problem. And then for your tests, if you haven't done already, I think I unlocked it again. If you did do it, then I'll try to upgrade the grade
I think
today.
I did both of them.
Okay, because I know you said that one had the passcode on it, so I think I went in there and fixed it so that it won't
Okay.
block anymore. Sorry about that one. So yeah, you bet, man. Have a good day. Be safe. If I don't see you guys, have a good weekend. Bye, girl. Be safe. Stay warm. See you later.